All right, now we're back in business. Okay, so this is where we are right now, ratio and proportion. So people at home, please take this note down, okay? So let's look at a problem that might seem a little difficult in terms of understanding at first in writing, and then how would we dissect this problem, okay? So if I gave you a triangle and I said the ratio, so this is an example right now, okay? So the ratio of the measures of angles in a triangle is as follows. It's 3 to 4 to 5. 3 to 4 to 5. Find the measures of these angles. Okay, so there's my triangle there. So how would we even set this up? Does anybody have any ideas on what this means, or 3 to 4 to 5, the ratio? Yeah?
Maybe side lengths.
They'd be side lengths?
Yeah.
Would they be side lengths, though? Is that what I'm given? These are ratios. You'd be right if they specify side lengths, but they're actually of the angles. Okay, so let's see. What would that mean in this case, then, in terms of the angles? What does the 3 and the 4 and the 5 have to do with anything with the angles? First off, let's start with anything that we know. Triangles have to add up to how many degrees? Okay, so we know it has to total. The total angle value, the total angle measure, has to be 180. Not just for this specific triangle, but for any triangle in general. Yeah?
It makes the proportions of the angles how...
Okay, yeah. Like how they all measure in size, right? So what looks to be the biggest angle? In the corner, right? The next ones are a little bit tricky, but what seems to be a little bit bigger? The angle... That one's smaller, you would say so?
No, wait. That one's bigger, sorry.
This one's bigger?
Yes.
Okay, so we'll say that that's 4, that's 3. So I might have already given it away by accident. But right now I have a triangle that has 3 to 4 to 5, right? But again, that doesn't quite make sense because we're saying essentially that the total angle measure of this triangle is 3 plus 4 plus 5, which if you can do in your head is only, like 12 degrees. So what they're saying is, though, what they're accurately saying is this angle here is going to be 5 times some value, 5 times big, as opposed to this side over here, and the way it compares is about 3 times bigger in some value, and this is about 4, okay? So what we're going to do is we're going to attach x values to these, and then we know that statement in saying that if we added these individual angle measures together, this is an angle of 3x. We don't know what x is. And this is 4x. This individual angle is 4x, angles, okay? Or degrees, I'm sorry, degrees. And then down the corner is 5x degrees. We know that they're going to equal in total 180 degrees. If we set up this problem now, is it possible to find x? Yes. Huh? Huh? I'm just asking you a question now. Can we solve for x at this point? Yeah. So we have like terms. We just add them together now. 3x plus 4x plus 5x is 12x. Wait, is it 12x? Yes, it is. 180 degrees. And you divide both sides by 12. X is going to equal what? What is x?
15.
Okay. 15. That's very good. So does that resolve our question in asking what the angles are? No. Because we know that the angle isn't actually equal to x, but it's actually equal to 3x in this case. So for this angle, you would have to substitute in 15. So 3 times 15, that is 45 degrees. Over here, you would substitute in for 4x. You do 4 times 15, that is 60 degrees. And over here, it's going to be 5x, which is 5 times 15. That is 75 degrees. So just as a check to see if 45, 75, and 60 will equal 180 degrees. If that is so, you have found a correct value of x that makes these angles correctly proportional or ratioed 3 to 4 to 5, as well as being a correct triangle. Does it check out? Okay, all right, then we are good. These are the correct angle values here, here, and here. Okay, I'm going to give you a new one here. Here's going to be your example. I think this one's a little tougher, and I think it's going to be kind of fun to do. Now, you have a triangle. So I'm going to shorthand this. You have a triangle that has measures of, let's see, the sides, sort of like what Elizabeth was alluding to earlier, of 2 to 2 to 3. And the perimeter is 392 inches. I want you to find the length of only the longest side. All right, go ahead and get to it. You may work together, okay? No whiteboard needed for this one. You may work at your desk or work on the personal whiteboard if you want, okay? Talk to each other here about what you would do. I'm going to walk around and see if anybody needs help. You guys okay on here? Sure. Yeah, can you just give it back? I like TV. Are you having any problems setting up your triangle here? So just take in mind, these are not angles now. These are the measures of the sides. So why don't you take that concept now and apply it to the sides instead of the angles?
Okay.
So it'd be like 2x, 3x would be the longest side. Okay? And then if you know the perimeter is equal to 392, what is a perimeter, by the way?
That's all.
Or all the sides added together to make 392. So set that up, and then you can plan. Everybody okay over here?
Yes.
Okay. You guys okay over here? Okay, so here, I know you're trying to do the angles, but let me ask you this. Oh, there we go. Sorry, and just remember we're talking about side lengths. So, are they degrees? The length of sides? Do I say the length of the scale is side? Yeah, and so to give you a hint, the unit is actually associated with the perimeter, which is your side. Okay. Awesome. There you go. Yes, it is. You are absolutely correct. All right, guys. So what you ended up finding out? You guys create a triangle. You guys might have noticed that there's a 2 and 2, so that's like a 2x, meaning two sides are about equal to each other. What kind of triangle would we call this, by the way? It's an isosceles triangle. And then you know the total perimeter is going to be equal to 392. So you guys added 2x plus 2x plus 3x. And if you combine like terms, that is, what, 7x. And then if I divide it by 7, what is x going to be equal to? What is it? 56. And then the length of the longest side, though, is not 2x and 2x. It's actually 3x. So you guys should have multiplied 56 times 3, which is approximately, or is exactly 186. Okay, great job. All right. And let's see, do I want to work on 3? Yeah, we already did that. Okay, now the next problem is going to be, requires you to set up a proportion. So you think you guys can handle this on your own if I give it to you straight. So let's do a challenge problem, right? This is going to be the last little challenge problem before we move on to 9-2. And now we're going to use this, the subtopic. We're going to say this is a subtopic within this section. It's going to be using proportions to make predictions. So let's say we have a total student body of 755 students. Who will drive to school? Okay? Who will drive to school? So this is a little bit statistical concept. Not statistical math, but the concept is still statistical. Okay? We want to know approximately how many students drove used cars to save some money, right? Actually, before I write down the rest of this sentence, how would you figure out how many people are, like, out of 755 students at a school? How would you know how many of them have used cars? What would you do to figure it out? It's not that easy, right? Because it's not easy to pick apart a used car in real life, right? Because some used cars are like, you're aware that most people, or like a lot of people, buy used cars from like 2017, and they're not like beater cars. They're like perfectly nice cars, right? How would you do it then? If you were at a school, how would you figure this out? In an efficient time, by the way, too. Let's say you only had like 2 days to do this. Yeah?
Sit outside the school, watch everyone come in and out, just count how many cars come through.
Again, how could you differentiate which ones are used and which ones are new, though?
What?
How could you differentiate? I'm asking you out of how many of them are used cars?
Oh, okay, used.
Yeah, what would you do, Alex?
Well, instead of doing what he did, I would create kind of like a checklist, like a paper, a survey.
All right, shh.
And probably pass it out to like everyone, like every student that goes, and then collect the data and then go through that one.
All right, and realistically, do you think you're going to get all the surveys back?
Probably not.
No, right? So, guys, in statistics, all right, you're going to learn in the future that statistics thrives on surveys and never getting back the amount that they want. But it's supposed to represent the population. Now, do you think it always represents the population, our results? So don't worry, I'm getting ahead of myself. So let's say this. We pass out a survey. To figure out how many. We pass out a survey to see who's driving used cars. And only 50 students return the surveys. Does that sound about right? Like only about 50, like out of like 750 kids would actually care. Okay. That's why it's kind of nice for you guys to help some people out with their surveys, because that's their job, is to try and collect data. If you can't help them out, then they might lose their job because they can't get people to help them out. Sometimes, if you have the time, of course, if your family's priority, totally understandable. Okay, so if we return the survey, and we found 20 found. I'm sorry. So yeah, that was right. Owned a used car. So based off of this information, we have to predict out of. So this is actually a lot easier than you might think. Okay, students. How many total students owned a used car? All right, guys. So this is your challenge problem. Please find out what that prediction should be. Okay? It's as simple as that. Yeah, it's not that bad. How would you set up this problem knowing what you know about proportions, right? Or ratios. So again, you have a total student body of 755 students. We want to know how many of them have used cars. We can't get them all to say yes or no to this question. So we have 50 students that responded, and only 28 of them have used cars. Actually, that's a good number. Yeah, it's over half. So how many students out of 755 should own a used car based on the data that we have? Okay, so 28. Okay. Nice. So Amelia, you share that with him? You guys already solved for it? You guys already solved it? So you have. Oh yeah. As long as you said it.
755 and then cross multiply.
You guys good so far? I'm just kidding. Okay. You guys did wonderful. All right. So how did you guys set this up? How did you guys set up this problem, man? Yeah? On. Shh. Ruby.
You could set it up as 28 over 50 because 28 people out of 50 people that returned it had used cars. And then you could cross multiply that with x over 755 because you don't know how many out of 755 have used cars.
All right. So this is the survey data, and then this is supposedly if the survey data perfectly represented the population, then we could set up two ratios and say that they're equal to each other. Okay. So if we do that, we could find potentially the number of people that have used cars out of 755 total. All right. We cross multiply at this point, and you have 50x is equal to what's 28 times 755?
21,140.
And then if you divide both sides by 50,
140.
140.
No, he meant it's 21,100.
755 times 28, yeah.
Is 420, approximately 423.
Approximately 423 used cars. Okay, very, very good. Just to let you know, though, or let me ask you, would this be wrong in saying this? So, for those few that are in my chemistry class, you guys might be able to answer this question. So, go ahead and don't answer that question. Is this wrong in stating that out of 28 used cars, or not out of, just like 50 total cars to 28 used? Is this incorrect in stating it in this way? Okay, I have a few yeses and nos. What do you guys think? Because if I try to solve, let's just look at it in a mathematical standpoint. If I had it set up like this, how would I set up the other ratio?
Set it up the same way, right?
Oh, is it? Well, is it exactly the same way, like x over 755?
No. You have to take the reciprocal.
So you have to take the reciprocal. So you just have to keep the units the same. 55 over 28 used is equal to 755 total, which is what you did, Alex, over x used. So in real life, in RL, okay, this is a perfectly viable way to state a ratio, okay? It does not matter the order. But if you're trying to find a proportion and set up two ratios, you better set it up correctly in terms of which units go where. I put 755 total now on the top as opposed to putting it on the bottom, okay? So it does matter, right? Anyways, one more question. This goes beyond the scope of just our math class, right? Do you think this survey perfectly represents a student population of 755, saying that there should be exactly 423 used cars? No, right? Why do you say no?
Well, it's just predicting based on data that you got from 50 students.
And folks, in statistics, that's what statistics is. You go into the math and saying how inaccurate, again, another prediction, you predict how inaccurate this value is. The math that goes behind that's a little bit more complicated. But again, this wasn't a tough problem, was it? Okay, statistics isn't that tough either, but it's the idea behind it that kind of makes it kind of confusing. Okay, so just kind of giving you a heads up for what to expect with statistics. Let's go on to 9-2. I think you guys are ready for this. I'm going to draw two quadrilaterals that almost look exactly the same. Okay. Two, three, four. Let me ask, I have two pairs of shapes here on the bottom and at the top. I'll say this. Both pairs are similar. One is perfectly congruent. Again, I'm going to say that one more time. Both of these pairs of shapes, meaning these two and these two, both of them are similar, but only one pair is congruent. Why is that? Okay, Ruby, go ahead.
Well, with the top shapes,
Yeah.
the angles can be the same, but that doesn't mean that the
Side lengths.
side lengths will be the same. But with the triangles on the bottom, if the side lengths are the same, the angle lengths are also going to be the same.
And also, how do we know that with these two triangles that if their side lengths are the same, that their angles are congruent? Does anybody remember that property of triangles? If their sides are the same, then they're congruent. Yeah?
The SSS.
That's the side congruence theorem. Okay, so just a little reminder here, because the fact that all three of their sides are congruent to each other, these two are congruent. And because we know that their sides are congruent, the whole structure is congruent, meaning that their angles are also congruent to each other as well. Congruent and similar. This, however, is just what we call being similar to each other. Again, the reason why is that all the angles are the same, but not their side lengths. So if you need to know why, the angles are the same, but the side lengths are not. There's one more element to being similar that I did not mention. Are you ready for this? So even though that these are similar, right, there's another element to being similar that I did not mention. Okay, so by the way, is there a theorem that says if all the angles in any shape or a quadrilateral are congruent, that means the side lengths are congruent? No. There's not. Here we had one. We had where all the side lengths are the same. That means the angles are congruent. Okay? Everything's congruent. That's the side. Just keep in mind, we never learned anything saying that all four of the angles are the same for a quadrilateral. That means the whole shape has to be the same as well. The side lengths, okay? We didn't learn any theorem like that. But what you're about to learn is this. 4. Let's say this is a 4, 2. Say that this is a 5 and 2.5. Let's say this is 6 and this is 3. What do you notice about the similar shapes? These are very deliberate numbers. Yeah, Georgia.
All of the side lengths of the smaller one are half of the side lengths of the bigger one.
And let's use a more broad and general term. They're not just half, but what do we say if they're all sort of this weird kind of ratio? 8-4, 4-2, 6-3. These are all the corresponding sides from 1 So this side corresponds to this side, and then this side seems to correspond with this side. Yeah, Yusuf. Yes. So what we can say about similar shapes. So what we can say about similar polygons, actually, anything that has more than one side, okay, excluding a circle, basically, they have the same shape, and angles, not sides, but not same sides, side lengths or side measures, side lengths, whatever, or overall size. And we also say that their corresponding side lengths are proportional. Okay.
I have a question.
Yeah.
So, in similar objects, they can never be congruent. They cannot have the same side length.
No.
Because that's what you said just there.
Oh, I'm sorry about that. But not overall. Let's see.
But not the same side.
Oh, but not. Let's see. But not necessarily. But not necessarily. Yeah. Thank you very much. So that is a very key word that I should have added. That not necessarily the same side lengths or overall size. It could be, because like in this case here, we had congruence and similarity. Actually, if you're congruent, are you similar? If you're completely congruent, are you similar? Yeah, you are. What is the ratio? By the way, what is the ratio of this side to this side?
1 to 1.
It's 1 to 1, right? This, however, could be a little bit different. Yeah.
You see that there too.
What?
Um,
Oh, here or not? Necessarily the same. Not necessarily the same. Sorry. Okay. That is actually very key to know that. All right. So here on an example that we're going to give, here is identifying similar polygons. So let's say that we have 4 different picture frames, okay, or 3 different picture frames, okay? We have a picture frame that goes from, let's say, E to F to H to G. That is 12 inches, and this is 14 inches down here. And then we have another similar picture frame. Or not yet. I haven't actually determined if it's similar. So seemingly similar then. Picture frame of J, K, M to L, right? This is 12 inches to 14 inch or 15 inches. This might be a dead giveaway right here, but are these two shapes similar?
no.
They are not, right? So how we would do this to set this up appropriately for proportion. You can do it in multiple ways, but here's one way, okay? Actually, let me write these in orange to kind of color code these, okay? In fact, if I could, I would have made this whole thing orange, right? Sorry, just so you can kind of follow my notes. So one way you can do this is set up a ratio between 2 corresponding sides of the 2 shapes. FG corresponds to what I believe is KL. And in theory, their ratio should be proportionate or equal even to, let's say if HG was the side down here, what is the corresponding side to HG on this shape? Theoretically. Before we actually solve for it right now. I know that they're not going to be perfect, but what should it be?
ML.
It should be ML. Let's see, this is the question. Are they equal to each other? That's how you determine if these shapes are similar. So we simply say that FG is 12 inches. And then KL is 12 inches. Sorry, that should have been color-coded to being orange. Is this in fact equal to the ratio between HG and K or and ML? So that is 14 inches on this guy, and then ML is 15. And I think you can already see that they're not, right? So are these two picture frames similar? Yes or no? These frames are not similar. Now it is going to be your turn or your try. Let's see if we can do DC. Let me try, or let me do another one now. Same thing, same kind of setup. This would be from A to B, and I want you guys to show me all the work. So this will be a whiteboard problem, okay? 8 inches, 10 inches versus, let's see. Again, JKML, 12 inches to 15 inches. All right, guys, let's just take a few seconds to do this. Find a space on the whiteboard. Please show me, so that way I can just kind of assess from right here in my chair, just a broad spectrum if you guys are getting this or not, okay? Quick assessment. I want to see if you guys are doing this. So this is going to be your example, another example. Are they similar? What's up?
A tissue?
I think I might. Let me check. You can use these dry towels, but they're not quite as nice and soft on the skin. So my apologies. How do you do? Oh, yeah. Sorry, I'm sorry.
What? No, I felt so wrong. You got that awkward. Did you?
Yeah. This.
Oh, this I didn't know. I didn't know that.
Oh yeah, I was like, I didn't know you could do this. It's pretty
No, it's not chocolate.
You should draw that every time.
Yeah, I definitely.
Well, let's check this again. We're gonna just show
I'm telling you.
Very good. Oh, so you cross one. Just simplify it down.
Oh, yeah.
Yeah, that's the way I was thinking. Yeah, I actually not prefer. I would actually see that more common.
That's definitely.
Fair enough.
Mr. Lee says he doesn't care what you like.
So what I would do is I would reduce this down to the lowest ratios so that you can't see it. Because you can't really. You guys figured it out. Okay. I thought you guys were so.
Sometimes it's harder to simplify.
Yes, it is. So yeah. You guys. That's the all right, guys. So first off, what were your? How did you guys set up the proportions? Now, give me the actual side lengths, not the actual values, but the side names. I'm sorry, or the labels. All right, I'm gonna pick on Jeremy. I'm intentionally trying to pick on you. Can you help me to set up this problem here? If I add BC, what side do I have to compare BC on to this guy over here?
AD.
To AD?
Oh, KO.
Yeah, KO. Okay. And then how about over here? DC over who?
ML.
All right. Thank you very much, Jeremy. Okay. So let's plug in the values. So I think that would be, 8 divided by 12, right? So you should have gone that should have been 8. Sorry if you guys can't see this. 8 divided by 12. I'm sorry. So I'm not going to color code anymore. It's becoming a little bit of a hassle, okay? 8 divided by 12 is equal to what value? 10 over 15. Okay, so I saw multiple ways you could have done this. One person did it this way. Actually, 2 people, I think. Cross multiplied, and that's actually perfectly viable because 8 times 15 is 120. If you cross multiply and both sides are equal, that is one way to see if your ratios were actually perfectly proportionate. You guys should have gone cross products that are exactly the same. Or I think what's more common, and I think a little bit more intuitive in my brain, is to reduce these fractions to the simplest forms. So up here, and how you do that as a reminder is you try to find common factors between your numbers in one fraction. I see 10 and 5 are both, the greatest common factor is 5, so that'd give me 2/3. And then the greatest common factor in 8 and 12 I think is 4, so that'd be 2/3 as well. If your ratios check out, then your shapes are similar. So let me give you a little bit of notation. A, B, C, D is similar. Be very careful. Yes?
Is it possible to the ratio BD to CD over, or like 8 over 10 equals 12 and 15? Could you do that too?
Yes, 12. Yeah, it's perfectly fine. The order doesn't really matter as long as it's consistent. You are comparing the corresponding sides appropriately to the corresponding sides. Or like if you do the order, like you do this corresponding side and this corresponding side, or you do 12 over 8, let's say, right? Like you did this corresponding side over this corresponding side, the order in the next ratio has to be the same. It has to come from this side, then over this side. Does that make sense? So be very careful too when you always name your structures. I went from A to B to C to D. The corresponding way that you would do that and name this quadrilateral would be from J to K to L to M. So this is how I do it. J, K, L to M. Okay? The order does matter in how you name your naming convention for your actual shapes. Okay? So this is my conclusion. A, B, C, D is similar to, similar to, okay, that's what it stands for. ABCD is similar to JKLM, okay? I'm going to move on to another problem. Again, I'm not going to give you direction on, actually, not again, because the last one I gave you direction. This one I will not give you direction for. Oh, that's kind of cool. Okay. Using similar figures. What time is it right now? Awesome. I think we still got time to get to 9:03 to find missing. What's up?
Which section?
This is still 9-2. My hope is that we can get through 9-3 as well. So I have rather unfortunate news for next week. I will not be here next week. So, I had one person go, yay. Kind of mean, right? No, I'm just kidding. I was just kidding, guys. So here's the deal. I did this with my AP Calc class. I'm literally going to make videos just like how I am right now. They're going to be in multiple parts, and they're going to be posted on my website. So where you download month 7 cover sheet, right across from the month 7 cover sheet will be a bunch of video links in order. Sort of like how I'm going in order like this. 9-2, I'm going to go through maybe a problem, then another problem. Then 9-3, I'm going to go through another problem and another problem. It's not going to be one long continuous video. So you take it to your, sorry about that. Yeah. You take it to your advantage, or you take it at your own pace. Yeah.
When will you make the video?
So my hope is that I can get piece by piece. I could start making them now, and then they're going to go up one by one. If it's a last minute thing, it'll literally be done hopefully sometime in the middle of Wednesday night, okay, to be perfectly honest with you. And I think legally there still has to be a class held. So I'm going to have a substitute that's probably just going to be here to play the videos for you, okay? So that's what I did with my AP Calc class. With them, I was a little bit more strict. I didn't give them access until the day that they were here. So like I just like uploaded them, then I told the substitute to play them. Okay, yeah.
Do we have to go to the class? We just watch videos and practice?
I'm gonna say, as a teacher here at MEA, I cannot say that you don't go to class. So come to class.
Should it be? Is it optional then?
I'm not gonna say that. I'm gonna say as your MEA teacher, you have to come to class. Okay.
I can't answer that question.
I cannot answer that question. Like at a personal level. I'm just gonna say professionally speaking, you have to come to class. Okay.
My parents were like, "Hey, son, we have to go somewhere today," and I'm like, "Yeah, we do."
What? Well, your dad said that. Oh, and
What if my parents are like, "Yeah, we have to go somewhere"? I'm like, "Yeah, we do."
if your parent can verify that and say that you have to go somewhere, then I can't speak against that. You have to go somewhere. So okay.
Classes are optional anyway, though.
I'm not gonna answer that. I'm just gonna say you should come to class, Matthew. Okay. I'm gonna leave it at that. Right? Okay. So I'm gonna say in this diagram, ACDF is congruent to VWYZ. Okay. And you might be wondering, what is he doing? What is he saying? Okay. Here's it looks like a trapezoid, but I'm not going to say it is a trapezoid. It's just a quadrilateral to be a little bit more specific. This side length is 12. This side length is 9. And this is X. Let's name it. This is A, vertex A to vertex C to vertex D, vertex F. And then I'm going to draw, I should have made this into a orange lettering here. Be very careful, all right? This is going to be 6. Sorry, I should draw this a little bit more. Let me see if I can do this. Yeah, it's a little bit hard to distinguish from my, there we are, from my drawing. This is from YZVW. Actually, this is a good exercise because Mr. Weed did not draw these very well at all, but unintentionally. I tried drawing it really well, but I didn't. Be very careful with the naming convention. It goes from A to C to D to F is congruent. So go to the naming convention here. V to W to Y to Z. I want you to please find X and Y. Okay? That is going to be your task for the next 10 minutes or so. Okay? Good luck. This is going to be you and your partners. Please talk to each other on this one. I'll raise the stakes a little bit. The first 2 groups that can find X for me, please let me know, and I will check the answer, and then you might get some extra credit. I have extra credit sheets ready to go for your classes. The key is I just have to log in everything now. So I still have all these random sheets of extra credit I still have to log in for your grades.
But would we need YZ, that measurement?
What?
On the second sheet? Yeah. Okay.
Sorry, Ruby. Thank you very much. Always quite inquisitive you are. Is that Yoda statement? Quite inquisitive you are. So my tip for you would be to use some known sides, okay, and set up your proportions that way. If there's a group that has found yes, Madadi. Okay. First, let me check the answer. Or else I'm just going there to just look at your answer and not even make sure if it's correct. Okay. Yes, good. All right, let me write down some names. Okay. Everybody. Did your sister and you, I think, unintentionally have a theme, like a Indian Ruby? Is that kind of cool?
What do you mean?
Like, I don't know, I just think of like India has rubies or something. So. Sorry about that. I thought those were. Alright, I'm not gonna. Yeah.
Alright, icebreakers.
Oh, is that
Icebreakers.
Is that what it is?
Sweet. So would you have found X and Y?
Squeeze it. Ice cream. Never really actually.
This is a lot of
No, you're not. I'm the second person.
All right, I think some of you guys are already getting this. Maybe some of you guys are still stuck. So let's help each other out here. So why don't we solve for x first? So why don't we solve for x? I'm going to draw this in green. Okay, it's a little bit easier. By the way, this is the month 7, week 2, technically. Yeah, week 2. Okay, so to solve for y, or for solve for x, what proportion did you set up? So you should have used a proportion, basically 2 ratios to set each other up. Please give me the names of the segments that you used. Okay, first, like AF over whatever, AF over ZV or something. Tell me what you used. Can someone please set up the proportion for me? Yes.
We did YW over CD, and then FD. No, YZ over FD.
Okay, so let's see. You did WY, or what is it? Yeah, WY, which is 6. And you did it in comparison to CD to 9. That is correct. These are actually corresponding sides that should be similar to each other if you looked at the naming convention. You also set up to YZ, which is 10, to, to FD. That is correct. If you look at the naming convention from here, F to D or D to F is the same thing as Y to Z or Z to Y, okay? You cross multiply, then you have 6x is equal to 90, and you divide both sides by 6, and you get, 15. Okay, very good. Thank you very much, Ruby. Okay, and let's solve for y. How did you guys, can someone help me with solving for y besides Ruby?
So I did YW over LF. No, not L. B. What is that? C. That's a C. Oh, okay. C. Wait, no. What?
Is my writing really that bad? I'm sorry. YW to CD? Okay.
CD.
Got it.
Yeah, I did this one. And equals Z. B.
Okay.
Over AU. I think.
You?
A. F. Mine's weird.
Give me some more credit. Yeah. Like, I thought I wrote that kind of clear. Yeah. I'm just kidding. Don't worry about it.
Mine's messy.
Okay, so these two are similar to each other, so that's why you set up that ratio. And then these two are similar to each other, YW and ZD. Same as what we kind of had before, 6 over 9 is equal to, 6 over 9 is equal to
Y minus 1 over 12.
12. And you cross multiplied. That is 6 times 12 is 72 times 9 times 3, y minus 1. You do the distributive property at that point to get 72 is equal to 27y minus, 9. You add 9 to both sides. You should have gone 81 is then equal to 27y. If you are very familiar with multiples of 3 and 9, you would recognize that if I divided these by 27, you would end up getting 3. Okay? Very, very good. Okay, you guys did wonderful. I think we have enough time to do a little bit more for 9-3. And if I have a good memory, which I don't, but if I have a decent memory this week, I can remember that we stopped at 9-3, and then I can continue on in the videos for next week from 9-3 where we left off, okay? Very hungry. Okay. Okay, so what do we got here? Okay, so in the same way that you guys have, actually, I'm getting ahead of myself here. You know what? Let's just start a little bit easier. Okay, so let's. Sorry. Got a little bit of stomach gas. Sorry, my apologies. Let's hone in on a similarity relationships in triangles, right? So if I drew to you two triangles that I'm not going to say are similar now at all, right? Let me say that this is, I'll say that's about 80 degrees. I'll say this is about 40 degrees. And again, this is 80 degrees and this is 40 degrees. I only have two sets of angles that are equal to each other in these two triangles. Can I say that these two triangles are similar? Yes or no? So I would at first definitely say, first impressions, no, you cannot. But why are some other people saying, I think so, yes? So my first impression when I look at this is like, you cannot tell that these are similar triangles. But again, some of you guys are kind of looking at this and thinking, I think they kind of are similar. Yeah, Georgia, how did you know that these are possibly similar?
They are because all of the interior angles they have to add up to 180, and there's only one thing you can combine with 80 and 40 to equal 180.
All right, so your total angle measure in any triangle has to be 180, right? So in both of these triangles here, they all have to add up to 180, right? So here, this would have to be 180. And let's call this X and let's call this Y, right? If 180 is equal to 80 plus 40 plus X, and I get 180 is equal to 120 plus X, what is X going to be equal to? 60 degrees. Over here, it's the same, sort of the same setup, but I say 80 degrees in this triangle plus 40 degrees in this triangle plus that mysterious Y is equal to 180. I might be met with a similar situation where you have 120 degrees plus Y is equal to 180 degrees. You subtract 120 from both sides, and yet you get something sort of, there's a pun intended, similar. X and Y are both 60 degrees. What does that tell us about these two triangles then? As a conclusion, if they are similar triangles. But here's what's even more significant, the takeaway from this. In this little segment here, what is it saying? What is the important thing to take away from this? How can we determine two similar triangles? How many angles do we need exactly to be the same? 3 exactly, but at the minimum, how many do you need? You only need 2 angles. So that's what we call... By the way, some of these theorems I've been giving you are actually in your book as theorems. I just kind of want to write it out for you guys, or like write them out with you guys. I just want to see if it kind of sticks in your head a little bit easier. This is actually in 9-3. So again, this is perfectly viable to put in a cheat sheet. If you're familiar with side congruence, angle for congruence, there are similarity properties similar to the congruent properties in saying that an angle similarity. If you have 2 angles in 2 triangles that are similar, guess what? Your 2 triangles are similar. Yes.
Are you
Huh? I don't think so, no. Potentially, yes.
No problem with proofs.
No, I can't do that.
Just skip this section.
No, I can't do that. I think this is a very honors content by applying similarity to proofs in the same way that you did with congruence problems. They're too easy? Is that how you're writing it off? It's too. That's pretty clever, saying that's easy, so you don't have to do it. But no, you're gonna have to do it. Okay. Are they? All right. So how can I make this a tough one here? All right. So I'll give you oh, actually, we are out of time, guys. It is 10:33. Yeah, we'll just stop right there. Okay. All right, guys. You guys have a wonderful day, and thank you for coming to class.